In this video, we are going to have congruency. So if you remember from the previous video from similarity, if you watch the similarity video, we shown that in similarity, the triangles will be similar to each other, but they won't be the exact same size. So what we did, we had two different reasons for similarity. And those reasons were actually corresponding sides are proportional, which means we have to prove that the ratios are the same for each proportional side of the two triangles. And then our second reason was to prove that every single angle was equal. Not every angle was equal. All the corresponding angles are going to be equal to each other for the triangles. We used angle, angle, angle as our reason. But now in congruency, the difference is now that the triangles will all be the same to each other. So if I give you these triangles, triangle ABC and triangle DEF. So as you can see over here, according to scale, we can see that this triangle ABC over here is exactly the same as triangle DEF. But if I were to add some information, and this is where we actually start with our reasoning. So we have about 3 reasons, and the third and the fourth reason that I actually want to go through is probably one of the more trickier ones. But let's just go through the 3 reasons that we have, and then let's start with our first reason, which is side, side, side. So now the information shows us over here, while we're using this reason over here, which is side, 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 as you can see I just added here, which is short for SSS. Okay, so right here, when we have triple S, or if we have side, 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 we are actually going to be looking at the sides, comparing the sides between the two triangles. So as you can see over here, we have triangle ABC once again, and we have triangle DEF. And we want to show that these two are congruent to each other. So when we are looking at side, 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 what that reason actually tells us is that the sides of each, all of the sides have to be exactly the same. The corresponding sides will be exactly the same. And this is the only difference here compared to the similarity. Here we have AB, right? We have side AB, which I wrote as X over here. And we have side AC, which is Z, and we have side BC, which is Y. And now obviously the same with the other triangle. But let's answer this question. What type of question would they ask in this situation? So our question over here says, show that triangle ABC is congruent to triangle DEF. So as you can see now, our sign changed now. Remember similarity, we had something like this. We had 3 vertical lines. But now for congruency, we have 3 horizontal lines. So how are we going to answer these questions over here? We're going to do the exact same thing we did with similarity. Our first step, we are going to be showing which triangles we are working in. So in triangle ABC and triangle DEF colon. Now we are actually going to compare triangles. Remember, our first step, we have to state which triangle we're working in, and then our second step, we are going to compare the triangles. So as you can see, side AB is equal to DE because it shares the same side, which is X over here, as you can see. So what do we say over here? We say that AB or side AB is equal to side DE, which is equal to X. And this over here is given to us. Now our next one that we're going to be dealing with over here is the second side, which is going to be side BC compared to side EF. As you can see, side BC has the side Y, and EF also has the side Y. So these two are the same size. So BC is equal to EF. Side BC is equal to side EF, which is equal to Y. And this is given to us. That is not a G, this is a G. It's given to us. And now our last sides that we are comparing over here is AC and DF. And as you can see, AC has the side Z and DF has the side Z as well. So AC is equal to DF in that case. So side AC is going to be equal to DF, which is equal to Z. And this information over here is given to us. Okay, now our last step is now to conclude. Remember our first step, which triangles are we working with? Second step, comparing the triangles to each other. And then our third step is to conclude. Therefore, triangle ABC is congruent to triangle DEF. And the reason that we used was side, side, side. And that is our method to finding the side, side, side reason. Alright, so if we move on to the next reason over here, we have side, angle, side. Now, I want you to take into consideration over here that we have the following information. And whenever we use side, angle, side, it must always be represented as side, angle, side. So you cannot write it like side, side, angle, and you cannot write it as angle, side, side. You can't write it like this, nor can you write it like this. Because the angle has to be right in the center of the two sides that are correspondingly equal to it, equal to each other actually. What do I mean by that? I just mean that this angle here must be in the middle of the two sides that are given over here, that are supposed to be congruent for these triangles, or supposed to be there for these triangles to be congruent to each other. And note how this one is also going to be here in between these two sides here. So with this specific reason here, the order really matters in this case. So let's actually get to answering the questions here. Okay, so how do we answer this one? We can clearly see that we are working with two sides and an angle, which is basically given over here. Side, angle, side. So we have two sides and one angle for each triangle in this case. So what is going to be congruent? Remember now they say show that triangle ABC is congruent to triangle DEF. Okay, now let's do the following. So we're going to state in triangle ABC and triangle D, that is not a D, EF colon. Now we're going to actually state what is similar, what is equal to each other. We can see that, okay, what we can see over here is that we have angle A is equal to angle D, which they both share the same angle X. So therefore we can say over here, angle A is equal to, note how I'm saying the hat on top, is equal to angle D, which is just going to be equal to X. And then the reason is because they gave it to us. It's given. Now our next step over here is going to be what is the same over here. We can see that AB has a side of Y and DE also has the side Y. So what we can say over here is that AB is equal to DE because they have the same side length of Y. And why are we saying this? It's because it is given to us. That's why we say that this information is true. And then the last one over here, the third one that we're looking at is going to be the third side, or the second side, which we can see side AC is the same as side DF because they both have the side length of Z. So we can say AC is going to be equal to DF. And our reason here is, or actually it's also equal to this, to Z. So we can see over here, and the reason why is because it was given to us. And now we can just conclude our answer. Remember, that's our third step. Therefore, triangle ABC is going to be congruent to triangle DEF. And the reason that we used was side, angle, side. As you can see, this order is really, really important. We have to say it in that order, side, angle, side. And if you say it in angle, side, side, or side, side, angle, it's not going to be correct. And therefore, those triangles will not be congruent to each other. Let's move on to the next reason. Okay, so here's our next reason, and our second last reason for congruency. So we have side, angle, angle. And unlike the last reason that we did, where the order really matters, with this one, the order doesn't matter. So you can actually work with angle, angle, side, or you can work with angle, side, angle. This one doesn't matter in this case. But when it comes to side, angle, side, you have to consider the order as side, angle, side, and none other. Okay, so like I said over here, you can use this, or you could use this as well. So now let's answer this question. We need to show that triangle ABC is congruent to triangle DEF. Now, as you can see over here, we first need to state which triangles we're working with. So we say in triangle ABC and triangle DEF, colon. Now we're going to say, what are we working with first? Now let's work with the side first. We can see that AB has the side of X and DE has the side of X. So therefore those two will be the same. So we'll say AB is equal to DE. So here AB is equal to DE, which has the side X. And what is the reason for this? They gave it to us. So it's going to be given. Okay. Then what's the next thing we're going to work with? We worked with the side. Now what we're going to be doing, we're going to work with the angle over here. So at point A of triangle ABC, point A has the angle Y. And we can see on triangle DEF, the point D, or the angle D, has the angle Y. So therefore those two angles have to be the same if they have the same Y value. Or they have the same Y value over there. So therefore we can say over here that, or we can say over here that angle A is equal to angle D, which is equal to Y. And why are we saying this? It's because it is given to us. Now, our last thing that we are going to be looking at is going to be our other angle. Because now we have at point C over here, it's Z, and point F over here, it's also Z. So therefore, angle C is equal to angle F. Which is going to be equal to Z. And why is this true? It's because they gave it to us. And now we just need to conclude our answer, because now everything is, now that we know that this triangle is congruent, we just have to state that now, because we can see that the angle sides, wait, what was this one again? It was side angle angle reason is true. Now we can actually say that triangle, or therefore triangle ABC is going to be congruent to triangle DEF. And here, the reason that we used was side, angle, angle. Remember, you can also, but I do recommend you can use it in the order that you work with. So you can see in this order over here, we worked with side first. Well, I'll just do it. We first worked with side, then we worked with the angle, and then we worked with the angle. So I recommend doing it in the order that you actually worked in over here. And as you can see, it's side, angle, angle. And let's just get into our last reason. So here's our last reason that we're using. So for congruency, our last reason is going to be RHS. And no, this does not stand for right hand side. but I did leave it in that order because it does look kind of familiar, but now it's actually going to throw you off. It looks like right hand side. But what it actually means is that, as you can see, what is different about these triangles that we've done previously compared to the ones we've done previously? As we can see that this one has a right angle and this one also has a right angle over here. And, okay, that's basically the only difference in this case over here. So that is what brings us to this reason. It includes our right angle. So therefore this R will stand for right angle. Right, I'll just say right angle here. So this R stands for right angle. And then this H over here, and if you know your Pythagoras, then you would know that it won't be Pythagoras in this case. Your R value in Pythagoras, I guess, is represented as a hypotenuse, not hypothesis. Hypotenuse. And hypotenuse is going to be the longest side of the triangle. Most preferably the opposite side towards the right angle. As you can see over here, this side over here that I'm pointing towards is opposite the right angle, and that's what we call our hypotenuse. So H stands for hypotenuse. We just do the spelling here. Hypotenuse. That does not look like a T. There we go. Hypotenuse. And now what does the S stand for? If you haven't been paying attention, then you would if you were paying attention, then you would actually know that the S stands for side. So there's not really much to understand about that there. Okay, so what are we trying to say? In this reason, we're going to be working with a right angle, a hypotenuse, and a side. Remember, that's what our reasons actually state. What are we working with? If it's side angle side, we're going to be working with two sides and an angle, and that angle has to be between those two sides. And if we're working with two angles and one side, that is going to be our angle side, and that means we're going to be working with two angles and one side, like I just said over here. But now in this case, right hand side, not right hand side, right angle, hypotenuse, and side. Those three we are going to be working with in these triangles, and we're going to be comparing them to each other. We are going to be comparing them within these two triangles that we have, which is triangle ABC and DEF. Now let's start off over here. We're going to obviously start off with in triangle ABC and triangle DEF colon. And now our first thing that we are going to be comparing, let's look at the right angle over here, right? Where's our right angle? We can clearly see it's at the angle B over here. And this right angle over here, there's also a right angle over here. And we know a right angle over here, a right angle is just going to be, okay, let me do it like this. A right angle is going to be equal to 90 degrees. That does not look like a zero. It's going to be equal to 90 degrees. Now, we can do the following. We can say angle B is equal to angle E over here. So we can say angle B is equal to, angle B is equal to angle E, which is also going to be equal to 90 degrees. And this over here is given to us. Now our next one over here is going to be, what are we working with? The next one is the hypotenuse. Now where's the hypotenuse? Remember I said it's the side that's opposite the right angle, which is going to be X in this case, or AC. So as we can see on triangle ABC, we have AC, which has a value of X, and over here, the hypotenuse of triangle DEF, side DF, which is the hypotenuse, has a value of X as well. So therefore they'll be the same. AC is equal to DF. So AC is equal to DF, which is equal to, it was X, right? Yes, X. And why? Because it was given to us. Okay, and then the last one we're dealing with is going to be the side. So what side did they give us? We can clearly see we have y over here. So AB of triangle ABC has the value of y, and then DE has the value of y as well. So therefore AB is the same as DE in this case. So AB is equal to DE, which is equal to y. And why? Because it is given to us. Okay, and now we can just conclude by saying, therefore, triangle ABC is going to be congruent to triangle DEF. Okay, this is actually our final reason that we have, and obviously it's going to be RHS, which is right angle, hypotenuse, and side, as you can see. So over here, all of this stuff that we compared, we had the right angle, which we were dealing with over here. Then we had the hypotenuse that we were comparing, and then we had the side, the random side that we were also comparing. That's what RHS stands for, and that is our points over here. And it's actually really simple. Now that actually comes to the end of our video over here on congruency. So we have covered similarity and congruency, and how do we use similarity and congruency. Now in following videos, I don't know about the next video, but I'll do examples from exam papers so that I can at least show you or expose you to the type of questions that they ask in the examination. And we can just go through it together, and then hopefully you'll understand from my teaching method over there. So this brings us to the conclusion of similarity and congruency examples and how to apply them with different reasons. And the next section will be on geometry of quadrilaterals, which is the final part of grade 9 geometry, or just my final part of just geometry, Euclidean geometry.